So, there's several different ways and things that we will use to estimate a derivative. We have already really estimated derivative sum in that very first part that we did when we were doing limits, where we were estimating speeds based on graphs. So if we're given this equation and we're told to estimate f prime of 4, so that means the derivative of f at 4. So this table gives us the values for f, not f prime. So what we need is the slope of f at 4. But just given these points, you can't tell what the slope of f at 4 is. So we can't actually find this value. But if we find the slope of the 2 points that are closest to 4, then that can estimate what the slope may possibly be close to. So in this case, these 2 points right here are points that are closest to 4. 4 would fall between the 2 and the 5 here. So we could say f prime of 4 is, and when we're estimating, it really is best to use the squiggly equal sign. I love the squiggly equal sign. It's like equals, but maybe not quite. Not quite sure if it equals this exactly. So squiggly equal sign is for when you're estimating and it's not exact. So if you remember, use this. A lot of times they won't count off if you use the equal sign, but it's more accurate to use this. And so these are the points 2, 11, and 5, 7. So if we're going to find the slope through those points, we're just going to do 11 minus 7 over 2 minus 5. So we'll get 4 over negative 3. So we could just say that f prime of 4 is about negative 4/3. Yes. Oh, yes. I'll finish recording this. If you take pictures and not take your book home, it's still from page 131 tonight. So, and we're probably not going to start the activity, so you'll just need to do that. I'll post that. Yes. Thank you. Okay. Good luck. Hope y'all win. All right. So the other thing that we're going to do here is we are going to estimate derivatives from graphs. And so use the graph of g of x. This is g of x over here to the left. And we're going to use that graph to estimate f prime of 0, f prime of 6, and f prime of 4. So for a, f prime of 0, we're looking at this point right here on the graph. And I have the advantage that I have, like a line that I can put here and kind of mess with a little bit to kind of get an example. You guys could use like a straight edge, or I've got some rulers I can give you in a minute if you want. But that's pretty close, I'd say, to passing through that point. So if we're just estimating that derivative, we're just thinking, if I have a tangent line through that point, what's the slope? So for this one, that one looks pretty close to about negative 1/2 for that one. So if we're estimating there, I'm going to estimate this slope is negative 1/2. Okay. At 6, let's see, these go by 2, so 2, 4, 6, 6 is right here. In this case, we don't have the equation, so we can't actually find anything. We're just guessing here. So if we put a line through here, kind of mess with it a little bit, try everybody get it? What that looks like. Pretty close, I'd say. And so sometimes it's a little hard to see, especially if you're estimating here, because nothing looks like it really hits on grid lines very well, does it? Let's see. Well, let's see. Here's a point. That's pretty close to grid lines. And that one's pretty close to grid lines. Let's count that one. So we'll go with that. So when you're doing this, of course it's an estimate. So if yours is a little different, that's okay. So the slope of this, we do rise over run. So we go up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6. That'd be negative because the line's decreasing. So negative 5 over 6. More than likely what you'd see if you were asked to do this is that it'd probably be multiple choice where you'd have, an obvious correct answer and others that were not correct. If you were ever asked to do it on pre-response, then they would give you a window of correctness there. What about at 4? So this counts by 2, so 2, 4. Uh-oh. I've got a problem here because do I have a point on the graph at 4? I do not. I've got a vertical asymptote here. So if this is the case, we're going to say this is non-existent. So anytime you have a discontinuity, and we're going to talk more about this some tomorrow, if you have a discontinuity, then the function's not differentiable. You can't take the derivative of something that's not there. So if it's not continuous, then the derivative just doesn't exist. Okay. The second question that we're going to be asked about this, true or false, for all x's in the domain of f prime of x is less than or equal to 0. We definitely got negatives for the two that we tried here. And since it says for all x's in the domain of f, 4 is not in the domain of f. So let's ignore that point. So, because it would give us some trouble because it just doesn't exist. So at every other point on this graph, we want to know whether or not, or is the derivative going to be less than or equal to 0. Basically means the derivative will be negative. So is that true or false? Okay. How many of you think true? Okay. Anybody think false? Okay. You're right. It is true. Because for this, no matter where you draw your tangent line, even if you draw it way over here, it's decreasing just a little bit, right? Over here it's really super steep decreasing, so it's going to be a negative slope. Then you jump up here, those lines are still decreasing everywhere. So it would be true for this one. That derivative is always negative because the slopes of those tangent lines are always going to be decreasing. They'll always be negative. Okay. All right. Your book has quite a few of these sort of things in it. And when I was doing the progress check, there's a lot of stuff like this. And I don't like it. It makes my head hurt. I feel like just looking at this seems confusing. But we probably need to do some more of this because I want all of you to pass that AP exam. So we're supposed to fill in each box here with a greater than or less than sign. And so they've given us stuff like f of negative 1 minus f of negative 3 all over 2. And f of negative 3 minus f of 5 all over 8. So there's a couple ways that you can look at this. On this particular graph, I could find f of negative 1. What is, let's see, Destiny, what is f of negative 1 on that graph? It'll be the y-coordinate. Okay, so negative 1's here. So on our point right here, what's our y-coordinate that goes with that? 6. So f of negative 1 is 6. And f of negative 3. Liliana, what would f of negative 3 be? It's 0. Because right here at negative 3, we have a y-coordinate of 0. All over 2, so that's going to equal 3 on this side. So this side right here, that's really 3. And then we could do the same thing over here, but we are going to have to do some estimating because f of negative 3, we just found that was 0. F of 5, I'm pretty sure that's sort of like a horizontal asymptote maybe there, but it's awfully close to 8, so let's just use 8 because we're estimating, so it'll be okay. Negative 8 over negative 8 equals 1. And so, obviously, 3 is greater than 1. So, if you have a graph where you can estimate the points pretty well, right? We had to guess a little bit on that f of 5, but not much. It's awfully close to 8, so we're probably not off by very much there. Plus, the difference between 3 and 1 is enough that even if we had said it was 7.9, it really is not going to change much here. So if you can figure out what the numbers are, you can do this. But sometimes they might give you problems where the graph is not quite so easy to read. So rather than plugging in numbers, let's think about what this stuff represents here. So this, f of negative 1 minus f of negative 3 all over 2. So f of negative, this looks a lot like slope formula to me, right? So if I was doing slope formula for this, I'd have f of negative 1 minus f of negative 3, and slope formula, it'd have to be over negative 1 minus negative 3. But what is negative 1 minus negative 3? Nope. Because both of these right here will turn to plus, so we'll get a positive 2. We get a positive 2, which is what they've got in the bottom right here. So what this right here is telling us is really the slope of the line between negative 1 and 3. So negative 1 and 3, we're looking at the slope of that line. And so when I see this notation right here, it's going to represent a slope. It represents the slope between what two numbers, Justice? The first one's between negative 3 and negative 1. What about this one right here? Negative 3 and 5. So, like on this graph, the point on the graph for 5 is right here. So, from negative 3 to 5, we're looking at the slope of that line. So, if you're just looking at slopes of lines, the red line is steeper than the green line. So, the slope of the red line is greater than the green line. So, you can do it without actually knowing the numbers also. So let's try the next one without knowing the numbers. Okay, so our first one is f of negative 3 minus f of negative 1 all over negative 3 minus negative 1. So, Wendy, that one looks like a slope formula to me. What slope do we have there? Slope between which 2 points? Negative 3 and negative 1. So it's that same that I have drawn on my graph there in red. Right. So then I'm asked about f prime of negative 3. So f prime of negative 3 is the slope of the tangent line. So the tangent line at negative 3 right here would be a line that barely touches the graph. The next one will be negative 1. We're still on this one. Oh, you mean the slope? I did. Thank you. Okay, here we go. Negative 3. How about this one? Okay. So, these are not, we can't really tell number differences here, right? So we just need to think about which ones, if it's steeper, it's going to have a higher slope. Well, in this case, because they're all positive slopes. So steeper is going to have a positive slope. A little less steep is going to have a lower slope. So in this case, which line is going to have the greatest slope for this one, Allie? Okay, f prime of negative 3. So that one is going to be greatest here. So we'll have that f of negative 3 minus f of negative 1 all over negative 3 minus negative 1 is less than f prime of negative 3. So that red line is a little bit less steep. You'll notice that C is almost exactly the same question, but I need to draw in that line I was trying to draw a minute ago. So if I draw in this line, f prime of negative 1, right here is where our x coordinate is negative 1. We're looking for the line that barely touches that. So Liliana, which line would be the steepest here? That slope, that red line, or the tangent line? The red is steeper here. So the slope between negative 3 and negative 1, that's represented by this expression here. So it's greater than f prime of negative 1. Okay, questions on that? There's not a lot of working out, nothing like 36 from the homework, but sometimes I think that notation can be a little tough. All right, here's our next one. Okay, there's one like this on your homework. We're supposed to label each of the following on the graph and find the values of each expression. So we're supposed to label f of negative 2. So whenever we label this, keep in mind, this is our x-axis right here. This is our f of x, or our, we could think of it as the y-axis, but I'm going to call it the f of x axis. There we go. So when I look at this graph, I've got f of negative 2, and so as soon as I looked at this, I was wanting to put a dot right here on the graph where x equals negative 2. That is the point there, but it is the point negative 2 f of negative 2. So that negative 2, the f of negative 2, that is 0 in this case. That's the y coordinate. So if we were going to label, it's kind of hard to label here, and also, let's see if I make it a little bit bigger. So this point right here on the y-axis, that is our f of negative 2. So like if we're numbering our y-axis 1, 2, 3, 4, 5, the 0 is your f of negative 2. Okay, for f of 0, we're looking at, here is x equals 0, we're going up to the graph. Right here is our point. And so, in this case, I guess we can just label this since it's on the y-axis. This is our f of 0. Destiny, what is f of 0? What's the value for that? 4. Good. So, algebraically, it's pretty easy to do the next part, f of 0 minus f of negative 2. So f of 0 we found is 4, and f of negative 2 is 0, so we just get 4 for that. What does that look like labeled on the graph? We'll skip that part. We'll come back to it. Okay. The next part, we've got f of 0 minus f of negative 2 over 0 minus negative 2. Again, algebraically, since we know these two, it's pretty easy to do. F of 0 is 4 minus f of negative 2 is 0 all over. That's going to be 0 plus 2. So we end up with 4 divided by 2, which is 2. So, fairly easy to do. How would I label this? What does it look like on the graph? Or what does it represent? What is that on our graph? It's our slope between the point 0, f of 0, and negative 2, f of negative 2. So, it's the slope of this little line right here. So let's go back to this f of 0 negative f of 0 minus f of negative 2. So it ended up being 4. Those are my y coordinates, right? And when I subtract something, I'm finding the difference between the two. So what this is here is it's the difference in y coordinates from f of 0 to f of negative 2. So it's that vertical distance there. So if you were going to label it, I guess I should put a line over here. On the graph, it would look like this. That slope, it would look like this. Okay. Again, on the last one, we could plug in numbers. So we could plug in numbers, but let's try to look and see what in the world this is here. Okay. So, first of all, what is this part right here? That is going to be, it looks a lot like slope formula to me. Between what points? We've got our 0, f of 0, and negative 2, f of negative 2. So we've got that slope between those 2 points there. Then over here I've got y minus f of negative 2. That's a y coordinate, right? So this is my y1. And then I don't have a minus right here, because this is supposed to be x minus x1. But what number did I have for my x? It was negative 2, because that's what it was, f of negative 2. So if I did, this is like x minus negative 2. So this is my x coordinate. So this is the equation of a line using that point slope form. So it's the point that goes through negative 2, f of 2, so it's right here. And then it has the same slope as the slope between 0 and 2, so it is, rather than just being this little piece right here, the slope of that piece It's this whole line right here. Okay, questions? Alright, we've got one more. Okay. Oh no, we've got two more, don't we? Yes, we got two more. Okay, we're going to do these fairly quickly. Alright, so 6 is easier than 7. But both of them ask us to sketch a graph of the derivative of f. And the graph shown here, this is f of x. So, remind me again, the derivative is the what of f of x? It's the slope of f of x. So this one is going to be fairly easy because all the way up to, I guess that's 2 right there because this is counting by 2's, we have the same slope because we have a straight line. So if we look at that line right there, nothing's on grid lines, is it? I should have zoomed in a little bit more whenever I did this graph because if you had little half marks here, I'm pretty sure that's right there at the half point. So if we went from like here to here, we go down 1, 2, 3, 4, and to the right 2, because this is having, so negative, over here we've got negative 4 over 2, which of course is just negative 2. And so the derivative is going to be the same everywhere for that, all the way up to this point. So we're just going to have, what we'll end up with is a, I guess I'll scale it the same, 2, 4, 6, 8, 2, 4, 6, 8, negative 2, negative 4. You guys get the idea, right? So, so all the way up to this point right here, actually, I guess I should. All the way up to this point right here, the slope, is negative 2. So everywhere that slope's negative 2. And then what's the slope of the graph on the other side of the graph? It's based on symmetry alone. I can tell this is going to be positive 2, right? So here we'll have this skips up to positive 2. Now this goes into what we'll talk about a little bit more tomorrow. What's the slope at 2? Can we really say there? It's negative 2 on one side, but it's positive 2 on the other. So right there at that bottom point, we can't really say what that is. So I'm going to use an open circle for both of these. We're going to learn tomorrow that if you have a sharp turn in the graph, then the graph's not differentiable. You can't find a derivative at that point. Okay. This next one, I think, is harder. I'm going to make myself a little table here, and I'm just going to make some guesses at this. So, I'm just going to, let's see, this graph goes from negative 6 to positive 6. So, I'm just going to use like negative 6, negative 4, negative 2, 0, 2, 4, 6. I'm just going to take some guesses. So, right here, at negative 6, what type of slope does it look like we have there? If we do a tangent line. If that's not just vertical, then it's got to be pretty close to vertical. So I almost think that looks like it might be undefined. There might be, it could be a really steep number possibly, but I'm going to go with undefined. So if I go to negative 4, that's this point right here. Oh gosh, let's just take a guess at it. It's kind of like -1. Pretty close to -1. Like if we're at this, well, maybe not quite. We're just taking a guess, so let's go with -1. We're estimating at this point. And then we're going to put us a point here at 2. This one, I'll use that same line and move it. This one's definitely not as steep. Maybe -1/2. Does that sound okay? We're estimating, as long as you put a number that's lower than this here and still negative, that's fine. What's the slope at 0? The tangent line at that point, I believe, that tangent line there, that's going to be horizontal. What's the slope of our horizontal line? It'll be 0. And then, so, just by symmetry alone, I can tell this is symmetric on both sides. So, whenever I get over here to 2, when I'm looking at that tangent line, I'll have a line that looks something about like that. That looks like it's definitely a positive slope, and just because it looks symmetric, I'm going to go with a +1/2, and then the 4, I'm going to make that a +1, and at 6, that looks like it's going to be just straight up and down, so I'm going to say inside. So if we want to sketch the derivative of this, thank you, Lily. If we want to sketch the derivative of this, I'm gonna not label mine like 1. I'm gonna make it a little bit bigger so we can see it a little better. So if we graph these points, alright, so if we just plot these points, I need one more. -4, -1 would be here. -2, 1/2 would be here. 0, 0 would be here. 2, 1/2 is here. 4, 1 is here. And then by the time we get to, I shouldn't have gone quite so far. Over here at 6, and over here at -6, by the time we get to those points, our graph has a slope that's undefined, so that is probably where we're going to have vertical asymptote. So the graph would look maybe something like this. So whenever you have the problems like this is what I want you to do. Just kind of guess what your slope is. Plot some points on the graph to get a rough idea of what this looks like. If I actually graph the derivative, because I know how to find the derivative of that equation right there. What is the derivative of x squared? No, I've forgotten it. 2x. Sorry. So if I actually graph it, it does look a lot like that there. So this is the actual derivative. That's the equation of it. You will learn how to find that before you know it. So, your homework is printed on there for you. So the 37 through 40, that's where you'll be sketching those derivatives.